Okay, good morning. So we're going to go over the lesson. Lesson 17M Part A. This is about math modeling using ordinary differential equations. And in this case, we have, say, a container of liquid. In this case, it's a container of water. It has a volume. V is the volume of the liquid. And let's say at the bottom of the container it has a hole. The hole, right? Liquid leaks out of a hole and causes the volume of the liquid to decrease. So the rate at which the volume decreases is proportional to the area of the hole and the square root of the height of liquid in the container. Now, so that's all this is really. That's all this is saying. dT is negative. Some proportionality constant times the area of the hole times the square root of the height of the liquid. H is the height of the liquid. A sub hole is area of the hole. K is the proportionality constant, and B is the volume of the liquid. Now, normally in a container, what you'll see is that this volume V is going to be equal to the area of the cross section times the height. So in this case, if it was, say, in a soda can, the water was in a soda can, right? Then the volume of the liquid would be equal to pi times the radius of the top or bottom of the soda can. So the area of the top or bottom of the soda can times the height. And when we plug this back in here, what we end up with, this cross-sectional area doesn't change, so we get the following formula. dT, rather, the area of the cross-section times dH dt is equal to minus K times the area of the hole times the square root of H. Okay? We can solve this equation then for the derivative, the rate at which the height of the liquid is decreasing, by minus K times the area of the hole divided by the area of the cross section times the square root of H. If you notice, if you bring dt to the other side, this actually ends up being a separable equation. And it can be rewritten as follows. H to the negative 1/2. Square root of H is the same as H to the 1/2. Multiplying both sides by H to the negative 1/2 brings H to the negative 1/2 to the left-hand side times dH is equal to minus K area of hole divided by the area of the cross section. Okay. So let's go over an example where we can use this to find how long it will take the liquid in a container to drain out. Now, what do we need to know for that? We need to know all these pieces, a few pieces of information. We need to know K, the proportionality constant, the area of the hole, and the initial height of the liquid. In solving this differential equation, we can find how long it will take the liquid to drain out. So I'm just going to bring this equation here. So, we also need to know the area of the cross section, so the dimensions of our container. So let's say a 10-inch soda can is a cross section in the shape of a disc. With radius, let's just say 2 inches. So that means here, the radius at the top or bottom soda can is going to be 2 inches. A hole, circular hole of radius 1 inch, is punched in the bottom. As you can see, okay, what happens, the water, the liquid, is going to leak. Cross section, 2 inches. Radius at the bottom is 1 inch. It's going to leak. Now, what else is going to happen? What else do we need to know? Well, we also need to know the proportionality constant. We need to know the initial height of the liquid, or the soda or water in our soda can. So let's say this was a 10-inch soda can. Let's say it was when can is half. So when can is half full, what does that mean? That means H, it's a 10-inch can. So H is 5. The hole's punched in the bottom of the soda can, starts leaking out volumes of water. And our question is, empty the water. So we know these initial conditions. These are the dimensions of the soda can, the dimensions of the hole, and also the initial height of the water. How long is it going to take the soda can to empty the water? How long is it going to take for the water to leak, all the water to leak out of the soda can through the hole? Okay, well, we need one more piece of information, and that is K. Let's assume now, let's say K is approximately 5. It's a experimentally determined constant. I think your book uses constant of 4.8. This will just make computation really simple. Okay, so now we have all this information, blah, 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 blah. We can plug and chug into this formula, solve it by, this formula is already a separated equation, and then plug in the initial conditions, that is H, so technically this is H of 0 is 5 inches, K is 5, and then we just need to say, okay, well, when is H, solve for T when H of T is equal to 0. So this is all blah, blah, blah. This is all word problem, blah, blah, blah. We can translate it to math, language of math, make it simpler. Let's see how that is done. 10-inch soda can, cross-section in the shape of a disc with radius 2 inches. So what does that mean? That means blah, 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 blah. Okay, The only really thing that's important there is that the cross section here is 2 inches. So a cross section equals pi. This is the area formula for area of a circle. Pi times 2 squared. What's the area of the hole? Pi times 1 squared. So this, all this, a whole radius, blah, 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 blah. Area of hole is pi times 1 squared. This is much more concise. That's blah, 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 blah. Okay. How long does it take soda can to empty water? Okay, well, just put this here. K is 5. H is 0. Yes, well, we already wrote that. Okay, so it really just reduces to solve. Solve this equation with these constants and h of 0 being 5 inches. Now this is going to give us formula for h of t. Once we have that formula, we're going to solve h of t is equal to 0. So let's see how this can be solved. Well, when we plug this in here, what do we get? Pi times 1 squared over pi times 2 squared is 4 pi. Pi times 1 squared is pi. This is 5, so this becomes minus 5 times pi over 4 times pi. That's the same as minus 5 pi over minus 5 over 4. So this equation here becomes h to the negative 1/2 dh equals minus 5 over 4 dt. We can slap on an interval there, and now we're almost done. Solving for h. Well, what's the antiderivative of h to the negative 1/2? It is, we just use the power rule, it's h to the 1/2 over 1/2 which is negative 5/4 t plus c. So what does that mean? That means we can, okay, now we can multiply both sides, say, by 1/2. This is just a constant, so we can keep it labeled as a constant. And we can square both sides to get the following. H of t is equal to negative 5/8 t plus c in parentheses squared. Now, we need to deal with this. H of 0 is equal to 5. So, h of 0 is c squared. That's the same as 5. So that means that c is equal to square root of 5. So we're going to plug it in here. Okay, so that's the formula. This gives you the height of the water in the soda can t seconds after the hole was punched in it. How are we going to deal with this? This is words. How long does it take the soda can to empty the water? We can translate that to the following in the language of math. Solve h of t equal to 0 for t. How do we do that? We set this equal to 0. We solve for t. So notice this is 0. If something squared is 0, we can solve for, that means that something has to be 0. So that means in this case, negative 5t over 8 plus square root of 5 has to be equal to 0. That means t is equal to 8 square root of 5 over 5. Okay, you can leave, if this was an exam, you could leave your answer like this, that's fine. If you want, you can convert this into a calculator, find out exactly how many seconds this is.